Alrighty, good morning. Welcome back. I hope the rest of your day yesterday went well. And thank you all here for being here on time. That's awesome. We're going to do some practice examples and exercises dealing with section 8.1 today in our confidence intervals. You might want to have your notes from yesterday available so that you can refer back to them as we work through these problems. We're going to do this using Pear Deck today. So it'll be a little different, not doing Desmos today, we're doing Pear Deck. So I'm going to put that link in the chat here for you. And please, if you are having any issues connecting to the Pear Deck, or if your device is not cooperating with it, please communicate that to me so I can help you or work out some other solution so that you can participate in the activity. Alrighty, and here we go. We're doing 8.1 confidence intervals, just the basics. Here's some examples in practice problems. All right, so we're going to start with our first example here. All right, the hot dog fat content. This is not an example for you guys to do. This is one that I'm going to explain and work through with you, just to get us started and refresh us on what this thing is all about today. So in this example, we're considering how much does the fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation, sigma, is 2.84 to 7.55. So in this example, their statistic that they're using is the standard deviation. They're not doing the mean or the proportion. They're choosing to use standard deviation. And that's fine, they can use that. All right. Question number 1 says to interpret the confidence interval. Question number 2 is interpret the confidence level. And the third one is deciding if this statement is true or false, that the interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation sigma. And we'll see a justification for the response to that. All right, so in question number 1, interpreting the confidence interval. Right, the interpretation would be the researchers are 95% confident that the interval from 2.84 to 7.55 grams captures the actual value of the standard deviation of the fat content of brand X hot dogs. Right, so again, the verbiage is important. Right? This should match up pretty close to what's in your notes for what we should say for a confidence interval. Right, we're 95% confident that the interval we found from our sample captures or contains the actual value of the standard deviation of the fat content. We're being specific. If you were to say we're 95% confident that the interval from 2.84 to 7.55 is the value of the standard deviation, that would be incorrect. Right? It is somewhere in there. It captures it. It contains it. Right? But it is not equal to it. For number 2, when we interpret the confidence level, right, we say if many samples of 10 hot dogs were taken, or if we repeated the sampling process over and over again from brand X, about 95% of them will result in an interval that captures the actual standard deviation of the fat content. So we're saying about 95% of the samples, if we repeated this over and over again, would result in a confidence interval that would capture the actual standard deviation. And lastly, for number 3, this is a false statement. This particular interval either does, probability 1, or does not, probability 0, contain the actual standard deviation. Right? So because it's referring to a specific or a particular confidence interval from a single sample, right? We can't say that it has a 95% chance of containing the actual parameter, right? Because it either does or it doesn't. There's no probability that it will. There's a 95%, there's 95% of our samples, if we did this over and over again, would contain the interval. The interval would contain the actual parameter. but each particular interval either does or does not. Okay, so we have to read these things pretty carefully to answer the questions properly. Right? Is there anything I can clarify about this example or explain in more detail? Okay. Then we are going to get started with our first question. All right, so question number 1, going to the problem. We need to determine the point estimator. The point estimator is a statistic. What statistic are we going to use? Sample mean, sample proportion, right? You would use and calculate the value of the point estimate. So determine what estimator you're going to use and what's that value based on the sample. Right? And we have the following context. Tanya wants to estimate what proportion of the seniors in her school plan to attend the prom. She interviews an SRS of 50 of the 750 seniors in her school and finds that 36 plan to go to the prom. Okay, so we're using this context to determine what's our estimator and what's its estimate. What's the value of it? All right, guys, before we look at what this solution should be, I need to clarify a couple things. So when we're determining the point estimator, we're deciding what statistic are we going to use. We get to choose one. We're not going to do a point estimator for the sample mean and the sample proportion and the sample standard deviation and the sample variance. We're picking one to be the estimator. And we have to pick that based on the context. From the provided context, what can we calculate? Right? What are we talking about? We're told that Tanya is estimating proportion. Right? That's right there in the context. So the point estimator should be the sample proportion. Okay? I can only pick one of these things. I can't find all of the sample things and all the sample statistics. I'm picking one based on the context. Okay, so based on that, we can use the given information to calculate what is the proportion of students from the sample who are planning to go to prom. That's specific, from the sample, not from the population. You need to differentiate between the sample and the population. Okay, I'm gonna give you all another minute here to look at this one and make corrections on your answers. Okay, so a lot of you guys have some parts of it. Right? It looks like some of you guys are getting to the actual solution. Right? And so remember, this has essentially two parts: identifying the point estimator and then telling me or calculating the value of it. So what we get is the following solution. The point estimator would be p hat, known as the sample proportion. And the point estimate, right, is 36 out of 50, or 72%, or 0.72. Right? In this case, the 750 doesn't come into play, the actual population size. Right? It just doesn't come up for what we're being asked to do in this question. Is there anything I can clarify? Or any questions that you might have?
Wait, I'm sorry. How come you didn't use the 750?
We don't need it to calculate the sample proportion, is the short answer. It would become involved if we were moving on to then find the distribution, the sampling distribution of the sample proportions. We would then need that because we need to confirm that our sample size follows or meets the 10% rule before we calculate the standard deviation of the sample proportion. But in this case, because we're not asked to go to that next step, we're only identifying the estimator and its estimate. We don't need the 750. It's just there to tell us the size of our population we're pulling the sample from.
Okay, thank you.
Welcome. Right. Let's move on to our next question. All right, this one has multiple parts, so you're going to get a little bit more time to work on this one. All right, so we have a poll that asked a random sample of U.S. adults the question, do you favor an amendment to the Constitution that would permit organized prayer in public schools? Based on this poll, the 95% confidence interval for the population proportion who favors such an amendment is 0.63 to 0.69. Part A is to interpret the confidence interval. So that's similar to what we did in the first example problem. Right. And then part B, what is the point estimate that was used to create the interval? Right, we're using a sample proportion, sample mean, right, what type of statistic is being used, and what was its value? Right, what is the margin of error? Right, based on this poll, a reporter claims that more than 2/3 of US adults favor such an amendment. We're going to use the confidence interval to evaluate this claim. Do as much or as little of this problem as you can. Just try your best. We'll see how to actually do this. This one will be a little challenging. Okay, so I know many of you are still working on different parts of this question. That's totally okay. In the interest of time and such and being able to get through the other problems we have planned for today, we're going to talk about this question now. I saw a lot of really good responses. A lot of you are showing that you have a great idea of how to answer these questions. Some of you hit it right on the head. Some of you were really close. So we're going to talk about this. Yeah. So on this slide here, we have our solutions, right? Now, it is important when you interpret the confidence interval that you write a statement saying the percent of confidence and what the interval is doesn't give us any other information than what was provided in the context. That does not answer the question. You have to give the statement. All right, so whoever the polling people are, right, they are 95% confident that the interval from 0.63 to 0.69 captures the actual proportion of U.S. adults who would favor an amendment that would permit organized prayer in public schools. You want to be as specific as possible to make sure that you're referring to the context, right? So that is some of the responses we've seen in previous questions already today. Part B, the point estimate that would be used would be the sample proportion. Okay, so saying what is our point estimator, sample proportion. All right, the value of that point estimate would be 0.66. It is the midpoint or directly in the middle of our interval. Because the interval is 95% confident, that means we're 2 standard deviations to the left and to the right of the point estimate. Okay, so it's right in the middle, so we do 0.63 plus 0.69 divided by 2, we get 0.66. Margin of error, right, would be 0.03 or plus or minus 0.03. Right, and we see that sometimes when you see polls that are shown on like news channels, they'll say margin of error plus or minus 0.0 something or point something, right? That's what they're calculating. It's the margin of error. Right? Because the value 2/3 is approximately 0.667 and values less than 2/3 are in the interval of plausible values, right? About half of our interval, give or take. There is not convincing evidence that more than 2/3 of U.S. adults favor such an amendment because it's plausible, right, based on our interval, that the actual value could be less than 2/3. So to make the claim that more than 2/3 would be in favor, it would be incorrect. It's possible, it's plausible, but we can't make that claim based on the evidence we have. Right. Is there any questions? Anything I can clarify before we move on to the next question?
How did you get well, the number 2, the 0.63 plus 0.69 divided by 2?
So that's the interval. So we have 0.63 to 0.69 is the interval. So that's the span of the plausible values. And the way that that is calculated is by adding and subtracting 2 standard deviations to the point estimate. Right? In this case, the sample proportion. And so we know based on that, because there needs to be symmetry, the point estimate must be right in the middle of those 2 values. Essentially, think of it as like a number line. We have 0.63, right, to 0.69. The middle is the point estimate, because we have to have symmetry to either side, the same plus or minus to each side of that. And so to calculate it mathematically, we can use the midpoint formula, if you remember from algebra or from graphing lines and things. So we take the 2 endpoints, add them, and divide by 2, and it gives us the value in the middle. Does that answer your question? Yeah.
Yeah.
Okay. Excellent. All right. Any other questions? All right, let's look at our next question. Choose. All right, this actually has a little bit of reference to a previous problem that we're not seeing today, so I'll give you that context as well. So the exercise 1 was that this class took an SRS of 20 girls at their school and asked how many pairs of shoes they have. So they have data for 20 boys and data for 20 girls. Right? They have a 95% confidence interval for the difference in the population means. Right? Girls minus boys. Right? And that gives us the interval 10.9 to 26.5. We want to interpret the confidence interval and the confidence level. Those are 2 different statements. Right, so we're going to write 2 statements for this. One is the interval, which we've seen several examples of today, and then the confidence level, which we saw an example of earlier. You might want to look back at your notes for that. All right, guys. We're going to talk about this one. So in this example, if you are performing any calculations, right, finding the point estimate, trying to calculate mean or standard deviation of the sampling distribution, the sample proportions, or the sample means, you're on the wrong track. That's not what you've been asked to do. Right? When we're being asked to interpret the confidence interval and confidence level, we are making 2 statements using the provided context. Okay, so we're making that statement about confidence interval. We are 95% confident, blah, 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 blah. And the confidence level. If we were to take many random samples of 20 boys and 20 girls and repeat this process of finding the difference of the means of those samples, right? About 95% of those differences, or about 95% of those confidence intervals of the differences of the population means, right, would capture the actual difference in the population means, or in the sampling means populations. Okay, those are the types of statements we're making. We're not performing a calculation in this example. All right, so we get 2 statements using the provided context and information. Right, so for the interval, they're 95% confident that the interval from 10.9 to 26.5 captures the actual difference, girls minus boys, in the mean number of pairs of shoes owned by boys and girls. For the level, if we took many samples of size 20 boys and 20 girls from the school, about 95% of the resulting confidence intervals would capture the actual difference in the mean number of pairs of shoes owned by girls and boys. Okay, so this particular question is not asking for a calculation. It's asking for you to show that you understand what the 95% confidence interval means. And we can interpret it by interval or level. Is there anything I can clarify? So now the next question also involves the same context, dealing with these shoes. You might want to remember that the 10.9 to 26.5 is our interval, as I should have put it on the slide and I forgot. So here's our next question. So does the confidence interval, the 10.9 to 26.5, give convincing evidence of a difference in the population mean number of pairs of shoes for boys and girls at the school? In other words, based on our interval, right, is it plausible, is it reasonable to conclude that there is a difference between the amount of pairs of shoes that girls own compared to boys? And use that interval as your evidence. Alrighty, we're going to talk about this. So think about this. We're trying to answer, does our interval, does the confidence interval give us reason to believe that there is a difference in the number of pairs of shoes owned between boys and girls, right? Whether that's girls have more pairs of shoes than boys on average, or that boys have more pairs of shoes than girls on average, is not necessarily what we're talking about. We're saying, is there a difference in the number of pairs owned? Our interval says that we're 95% confidence that somewhere between 10.9 and 26.5 is the actual mean difference of the means, or average difference between the pairs of shoes owned, right? That gives us pretty convincing evidence that the difference is not zero. Right? If there was no difference, we'd have zero as a plausible or possible difference, and we don't. So that's what we get as our solution here. Yes, all right, we have convincing evidence. All right, since the value of 0 is not a plausible value in the interval, there is convincing evidence that there is a difference in the population mean number of pairs of shoes for boys and girls at the school. Right, we can safely, right, confidently rule out no difference as a plausible answer. Therefore, we have evidence that there is a difference. Right. Is there anything I can clarify? Okay. All right, the next couple questions are multiple choice, so we won't have to spend as much time on these ones. So let's look at that. Okay, this is a multiple choice question in a poll. 1, some people refused to answer questions. 2, people without telephones could not be in the sample. Or 3, some people never answered the phone in several calls. Which of these possible sources of bias is included in the plus or minus 2% margin of error announced for the poll? You can choose from 1 only, 2 only, 3 only, 1, 2, and 3, or none of the above. Okay, so those 3 possibilities, right? Those are examples of bias, right, that we may have heard of or seen in chapter 4, right? And right, some people refuse to answer questions, right? So non-response. People without telephones could not be in the sample. It's under coverage, right? Some people never answered the phone in several calls. Non-response. These are types of essentially like response bias. Okay. Our plus or minus 2% margin of error can only account for error or bias resulting from chance, right? A sampling bias, meaning that it's just possible that from the data we collected, we're a little bit off here and there in our sample, and that's essentially because each sample will result in a slightly different statistic. Right? That's what that margin of error accounts for, is that sample to sample will get slightly different results. It cannot account for other forms of bias, such as response bias. So the answer is E, none of these. Right? Those are all examples of response biases that we cannot account for in that margin of error. Margin of error simply accounts for the fact that from sample to sample we'll get slightly different statistics. Is there anything I can clarify on this one? We got one more question. Here it is. Right. You have measured the systolic blood pressure of an SRS of 25 company employees. 95% confidence interval for the mean systolic blood pressure for the employees of this company is 122 to 138. Which of the following statements is true? Read these carefully. One of them is true, the other four are not. All of them have some parts that could be true, but we need to make sure that the things are in order and using the right verbiage. All right, so read carefully. All right, so last question here. The correct answer was C. All right, I'm very happy to see that most of you guys are split between C and D, who responded, which are pretty similar. All right, so C, if the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean systolic blood pressure. This is a true statement. The other ones all had some slight flaws in their wording or in what they were saying, right? Is there anything I can clarify on this last question? All right. So I'm gonna stop this one here. All right. So that's the practice problems for today. I do highly recommend, once again, that you look at the resources available for section 8.1 in Canvas. There's a study guide, there's other practice problems, there's some example videos from the textbook that are all available in there. They're all good resources. There's no specific videos from AP Daily on 8.1, but there's many videos for 8.2 and 8.3 that I've already linked in those resources if you want to jump ahead. And that if you have any other questions or you need any other clarification or help with anything, please stick around and let me know or send me a message. And that, have an awesome weekend, and I will see you guys on Monday for the T lesson. All right, so don't forget about that. All right, see you guys next week.